The Earth has earned itself some pretty special nicknames, including the blue marble and the pale blue dot. When we look at our planet from space, we see that our largest feature is our oceans. Because they're so big, it makes sense that they would play a key role in sustaining human life on this planet. There are several ocean features that are useful for creating climate models, such as surface temperature and water saltiness. However, they can be difficult to observe. My dissertation work focuses on one of these many features, and that is ocean color. Observing something as simple as the water's color is actually a powerful measurement. Ocean color shows us neat things like current patterns and the size and location of phytoplankton blooms, like the one on the slide. So studying features like these show us how the ocean is actually changing with the climate. So imagine you're a fish swimming around trying to observe and study your little fish neighborhood. Your worldview is limited to the small chunk of ocean you're able to explore, and it's unfair to assume what the remaining ocean is like based on your observations alone. Using satellites, we have the privilege to explore and observe the world in ways that are larger, expanding our perspective from that of a fish to a bird. My work focuses on technology designed for tiny spacecraft called CubeSats that are roughly about the size of a loaf of bread. These spacebirds are small but mighty. They offer large-scale views of Earth using platforms that are fast to design and build, cheap to manufacture and launch, and are able to collect high-quality scientific measurements. Our CubeSat uses a fancy camera to image the oceans from space. So your typical, everyday camera takes pictures using 3 measurement bands, red, green, and blue. Our CubeSat's camera takes pictures of the oceans using hundreds of bands, allowing us to uncover the surface features hiding in between those 3 colors. My job is to show that this multi-band camera is sensitive enough to capture good ocean images. Climate scientists need clear and detailed images to identify patterns and changes in ocean behavior, and I'm working to develop a math model that proves that we can provide those useful images for the scientists. My model simulates the path of light from the sun, bouncing off the ocean surface and back to our spacecraft. Now, that light encounters many obstacles along the way that cause it to lose its strength before we can actually capture a picture. My model predicts the amount of light left and tells me if our camera can use this light to create a bright and detailed image. The oceans are vast and mysterious, and while we don't know a ton about them, we do know that we need to work hard to understand and protect them. Collecting fresh data about our oceans from space helps us do just that. My work to improve spacecraft imaging practices will help us better understand the oceans and consequently the effects of our changing climate.